long form title could be better composed as a tale of greatest good for the greatest number. And I'll try my best to explain throughout the process of this 15 or so slides the various efforts that we have been putting together to make it a responsive, responsible, accountable, and a transparent system at every level. And to begin with, we started out with a couple of goals and objectives 4 years ago when Michigan Tech didn't necessarily have a centralized computing infrastructure or a shared computing infrastructure. So the goal number one was to design and implement a system that was stable enough for carrying out computational sciences and engineering simulations that lasted a week or two or even months at a time. Not only that, we have a diverse group of faculty members that belong to various different departments. We wanted to name the machine in such a way that everybody took pride in the name. So the easiest politically correct name that we could come up with was Superior, because the geographical proximity to the Great Lakes that we are in, and the building in which the machine was housed was called the Great Lakes Research Center, which was part of a Michigan and state of Michigan and Michigan Tech building grant. And we also wanted to kind of convey the sense of grandeur that it was bigger than anything that we had at Michigan Tech until that point, since Superior is the biggest of the Great Lakes, so we chose that name for a lot of reasons. Uh, Added in those goals and objectives was to make sure our researchers did not do any systems administrative tasks. That would all be my job, and they would spend time in writing proposals, getting money, teaching. If they still had time left over, spend it with their family and friends, but not on systems administration. And the last but not the least was to create a sense of transparency and responsibility and accountability for every party, including the infrastructure and the system. And by infrastructure, I mean the computing cluster in itself had to be up and running for longer periods of time, which was my responsibility personally. And administration was responsible for making sure the system did not break down by making any kind of exceptions to any one person or one researcher. And researchers had to be transparent and accountable in using the machine the right way, in line with the compliance and the expectations that we had set for them. Goal number two, once number one was achieved, was to make sure we had some kind of a tracking system with which we could measure the tangible entities, such as how well is the machine being used and what can we do to show return on investment, not only for our administration and to the state of Michigan, but also to potential funding agencies and donors and administration in itself. And last year, when I gave a talk on streamlining shared computing infrastructure at Michigan Tech, Rich from insideHPC and Amber from ISGTW did a phenomenal job of documenting it for eternity. So that has a very long description of where we went from and where we were as of last year. Uh, there was a glimpse of what is in this presentation in last year's talk, but we didn't have enough data to back it up about how our policies and procedures were working. And now that we've had about 20 months of data, I'm more than confident to talk about what we're doing right now. As of now, we have about 1,400 cores on campus between two machines. Superior is the biggest machine for research and primarily research. Portage is a small, tiny little canal that connects to Lake Superior in our backyard. So it's a philosophical or a computational segue for educational projects and classroom projects and senior design projects, and people that have never used a computing cluster. They use Portage, and once they exceed those resources, they get on Superior. And over the period of last 20 months, we have averaged at least 85% on most days, 90 plus and 95 plus in last month and a half or so. We're very proud of how much it's being used. So there are two driving philosophies. The biggest one is called the greatest good for the greatest number. We wanted to set up a system that was most useful to most people at Michigan Tech, which meant some people would go unhappy. So, and we were okay with it. And that quote came from our chair of our HPC committee, and it's a committee of one. So you might laugh at this, but it has helped us get a lot of work done a lot quicker. So I'm the technical committee. My Dr. Ferger is the chair of HPC committee, and our CIO is the chair of political committee. Everything is a committee of one. We more often than not meet in a downtown brewery and hash things out and take care of things and without crossing each other. Uh, as Gifford Pinchot put together greatest good for the greatest number in terms of sustaining natural resources in early 1900s, John Muir, the wilderness prophet, put together a quote as well, like these kind of policies are okay, but the greatest number usually turns out to be one, and that's the person with the money. So we wanted to kind of make sure we kept both Gifford Pinchot happy and John Muir happy, and in turn keep Teddy Roosevelt proud of our system. If he was designing national parks and looking for ideas, he would be proud of this system. So we chose not to make any exceptions for anybody, and money is a concern. We take every shade of green that can come into Michigan Tech, but at the same time, no one person will dictate what can be done with the machine and how it can be used. The other driving philosophy is with regards to managing resources. This is something that I came about a couple of years ago. What I cannot manage, or what I cannot measure, I cannot manage. What I cannot measure, I cannot manage. And we understand that not everything is easily measurable and not everything is really useful. So we had to take a combination between the two. And I'll talk about what these entities are as we move along the way. So how do we go about implementing these philosophies? It's very, very simple and straightforward. And just like the NSF or any other funding agency, even though the machine is free, we wanted them to be accountable, let us know what they're going to do. So that way, if they end up doing Bitcoin mining, we could hold them responsible for it and get them off the machine or use the resources for something else. So everybody submits a resume and a very brief proposal, and we encourage graduate students to do this part so that way they get some experience and the PIs just attach their resume and send it off to the committee. And it also includes nature of data sets and any kind of resources they need, and if there is any source of funding. And this is necessary to kind of classify the projects in compliance with federal and funding agency guidelines, HIPAA, FERPA, HITECH, and ITAR, and all those things. The chair of our committee reviews them usually in a matter of 4 to 6 hours and assigns them a tier. Class A is every new faculty at Michigan Tech and every researcher that already has some kind of funding that can be set aside to upkeep the machine. And Tier B is for every established researcher that doesn't have immediate funding. New faculty are in Tier A because we're not giving them individual startup money anymore to build their own cluster, so they have to use what's available in-house. And we want them to do good enough research to move towards tenure so they get the highest priority. And within the queuing system, we are married to ROC's cluster distribution. We use the same thing for every computing cluster we have, including hands-on projects and such. And we use the grid engine queuing system within that one to manage our resources. And every software, I have configured it to be a requestable and a consumable resource. And the job submission scripts are designed in such a way that they have to request a resource before it can run. And the idea behind this is as soon as they requested, the queuing system logs contain that information that I could then parse and see how many times MATLAB was used and how many times COMSOL was used, and should we even worry about renewing the license, paying $20,000 for a software that we only used once per year. And in creating user accounts, I use a very in-house scheme. Usernames are identical in the cluster as it is within our banner system, but the PIs or their advisors' username becomes the primary Unix group within our computing clusters. And this is also important because this information goes into the queuing system log as well as the primary use group that they belong to, so it makes it easy to classify group by group usage data. And I keep an SQL database outside of the queuing system that keeps track of what department they belong to and what college they belong to. So that way for a university executive, they could look at the bird's eye view of college by college usage or a department by department usage, or even drill down to research group usage if they like to. So Easily measurable quantities are fairly easy. We know who they are, what their username is, and who they are within Michigan Tech as well. Are they a student, or a postdoc, or a faculty, or a visiting scholar, or an industrial collaborator, and such. And from the queuing system log, we could also very easily get how much CPU time they used and how many CPUs they used and what kind of software they used, because the token gets into the queuing system log. Something that's difficult to measure but really meaningful are how many publications have you produced, how many citations each publication has gathered, how many graduate students have you produced out of your research group, and how much money have you brought in from outside resources. Publications and citations are useful because they kind of show the value of work that you're doing. And graduate students, we believe, good graduate students anyway, add value to the society once they leave Michigan Tech. We haven't yet implemented a numerical score for them, but that's in the works. Successful proposals kind of show the confidence in the society, in our university, and our researchers when they do get funded. So that's a criteria for measuring their production within the university as well. A really interesting term that I learned last year from Rich is called human engineering. Last year, at the end of my presentation, his question was consolidating machines was probably easier compared to the aspects of human engineering, kind of herding the cats per se. Last year, my answer was no, because the first 100 users of our computing infrastructure were the ones that didn't have anything before the machine came along. So they knew the pain of not having something that good, that well maintained, and that big. So they were willing to easily buy into our concepts and philosophies and policies and procedures and use them very meticulously. But the second 100 users or so that have come along, they're brand new. They don't know what we didn't have before, so they expect to have these things. So there is a little bit of sense of entitlement, for lack of better word, that we need to deal with and work on how to implement, help them understand what we have and what they couldn't have before. And we accomplished that using new user training sessions. A technique that I learned as part of one of the sessions in supercomputing is to create an account, give them 30 days to read and understand the instructions on the website. But within the 30 days, they had to schedule a one-on-one training session with me. Beyond that, their accounts get disabled and they no longer can use the machine. And on every computing cluster's website, we have enough information for Linux command line tips and utilities, and information about conferences and upcoming webinars and all that good information. And I also conduct 2-part graduate level courses in scientific computing, one in the fall and one in the spring. The demo that you saw from Steve Jones yesterday about building a computing cluster is part of the UN 5395 syllabus, and each student gets his or her own little cluster that they build out of retired computing nodes. So the idea there is to kind of help them understand, if they go to a small enough university with no IT, they still should be able to get their infrastructure set up on their own, do enough research, understand the idiosyncrasies of funding agency guidelines and federal regulations, and protect their data in a way that's compliant with all those guidelines, and not go to jail and take their IT with them to the jail. The UN 5390 has a lot more numerical methods and revision control systems and active compiling programs and parallel computing and such. UN 5395 is more, like I said, an advanced course, treating them as if they're brand new faculty in some university and helping them move along the way. We also keep track of violation. Anytime they do something dumb, there are self-policing algorithms or scripts that only punish the wrongdoer, not everybody else. A classic example would be running something on the login node where they're not supposed to. So that kicks them off the first time. Second time, it kicks them off, copies their advisor, and locks their account. And every subsequent similar act counts as a violation that we keep track of in a separate file. And exceeding allocated disk quota is another form of violation. And something that we had to learn along the lines of the national park system was we have a general set of rules that we started out with. If a newer issue that came in fell within the realms of that original scheme, it was fine. If something new came along, we would consider that as an exception, deal it on a case-by-case basis, and incorporate that into the general scheme of things moving forward. So the last bullet point here is something that we've been dealing in the last month and a half or two, where one or two graduate students have been somewhat irresponsible in posting comments on social media. So we understand there is the freedom of speech and right to independent opinion and thought, but what we are trying to implement here is a layer of common sense on top of it. So that way they understand where to vent their thoughts and frustrations and what channels they should use. In effect, we want to make sure they're not jeopardizing their chances of getting a job once they graduate, also not jeopardize the chances of a reputation of the university and the infrastructure that we are using, given you all as industrial partners and collaborators are also on social media. If you see something bad about me or my school or my infrastructure, there is little chance of you taking any interest in funding my projects moving forward. And even though it's my project, it affects everybody else in my university as well. So we're trying to kind of train those things, and central administration has been very helpful in making sure the faculty understand and they pass along similar messages down the channel to their grad students as well. So with regards to transparency, I have a system that sends every PI a report every Monday morning, 5 minutes after midnight. It includes information like how many jobs did everyone in their research group ran, how much time it took, what was the CPU and wall times, and if we didn't have the infrastructure that we have right now, how much money would they be paying out of pocket to get the work done in something like Amazon Cloud Service or Google Cloud Computing. So the cost is very cheap, 10 cents per hour per CPU core. We don't charge them anything, but it's still there as a value-added resource. The idea came from dealing with one of our vendors and community business establishments where they gave free service to one of their customers, and the customer came back asking for a free service the next time something got broken. So subsequently, the vendor made a deal. Okay, here is what would have costed you. I'm giving you 100% discount. You're not paying anything, but next time it'll cost you that much money. The executive team gets this report once every 3 months, or anytime there is a need, or anytime they have a visit from the governors or the senators. They can ask for me, but it's always there for them as well. And finally, it comes to how do we compute priority, taking all these things that I've talked about into consideration. So a very simple formula is the job priority is a combination of two functions. One, a function G of raw CPU time and the total production. G indicates the group level credit. We subtract from that number a function U of violation, U which is at the user level. So if I did something dumb, I'm the only one being held accountable for it. My rest of my group doesn't get the punishment. And how do we measure raw CPU time? We want to make sure somebody just doesn't run an infinite while loop for a year saying hello world and claim that they actually did some work. So we only give 35% weightage on CPU time that they have used. And that can be easily extracted out of the grid engine queuing system log. And we retain the CPU usage in time units, but production we put a 65% weightage, and that includes funded proposals, publications, and citations. Each citation counts as 1/10 of a publication, and conversion factor for publication could be a journal, could be a conference proceeding, or a poster, or a book chapter. Depends on what type of publication it is, and we have internal conversion factors for those. And every dollar they bring in counts as 10 CPU hours, because that's the model that we're charging them per se. And within the grid engine queuing system, job priority is just a number between -1023 and +1024, and it higher the number, higher is your priority, and you had to be either an administrator or really good to me to get a number higher than 0. As far as being a normal user, you could only control a number between -1023 and -1. And once you assign a number, even on your own, you could only go lower. You can't come back higher. So we use these things to our advantage. And here is a schematic representation of how the priority gets computed. So we extract the raw CPU time and production from the grid engine log and the MySQL database that I keep track of publications and funding in. And then we pose a question, are you a brand new faculty? If yes, so we give you a -1 priority. And if you're not a brand new faculty, we ask the question, are you in tier A or tier B? If you're tier A, we map you between -501 and -500 and -2. If you're not a tier A faculty, we give you between -1000 and -501. And eventually we subtract your individual violations from that number. That becomes your priority for your next simulation. So far, it's been working really well. However, if we notice that the group level interaction isn't there enough or to the point that we expect it to be there, say, for example, advisors not taking enough interest in how well the system is being used or how well their students are behaving, we plan to implement an NFL-like penalty. So unsportsmanlike conduct costs you 15 yards for the whole team, not just for yourself. So we'll apply group level violations and subtract that number so the entire group ends up paying for any one of their penalties as well. So what we have for results are the following. We have about 40 projects going on, 50% tier A and 50% tier B. And within tier A, about 10 of them are brand new faculty that are getting along just fine. And within 20 months, we have published about 30 papers, and 20 more of them are in the pipeline. As I mentioned before, we have about 90% usage on most days. And on the 10 cents per hour per CPU core model, we have used it to a tune of about $1.2 million in 20 months. Remember, the initial investment was $750K. Researchers have brought in enough money to another $200K or so since then. And in spite of all that, it's about 140% usage recovery and everything that we have invested. And even though the next point is some kind of subjective, not very objective, I'd like to believe that there is more sense of an ownership as to what we have inside and feeling a little more accountable in using it well. Primarily since they have come to realize that the ball is always in their court to do the better work and earn a higher priority for their subsequent simulations. And I'd like to say we are a fully happy research computing community, but that's not yet the case. It's mostly happy. There are a few unhappy folks here and there, and we'd like to address them one at a time as we move along. And the links below are kind of take you to a list of projects and publications. And analytics page gives you a week-by-week usage of how much money has been recovered. And it also contains high charts, interactive graphics on college usage, department usage, usage by memory, usage by number of processors, and wait time, and all that stuff. And in the near future, what we plan to do are the following. Like everything that I have discussed so far, and then some, are part of 2 manuscripts that are about to be reviewed by a journal. And as and when the publication is, our manuscript is accepted for publication, the code base and everything else will be made available for public consumption via GitHub repository, so anybody that's interested could implement it. And we also understand that not every publication is created equal, so we'd like to have the impact factor incorporated into this priority computing scheme as well. So something like an XML file that has an annual list of impact factor of each journal would be super helpful along those way. And collecting citations has been the most time-consuming part right now. I spend anywhere between 2 to 3 full days or a weekend checking through how many times even my own publications have been cited. And I do have an app that kind of visually represents your publications or citations as to where they're coming from on a Google map. if only Google Scholar program would let me query the list of citations by providing a DOI, that would be supremely helpful, and I could automate that process so that way we could update that map and everything else on a daily basis rather than once a month and uh, still having the potential of missing out important citations. And finally, I'd like to thank Phil, Luca, and Rick from San Diego Supercomputing Center, the folks behind the ROCks cluster distribution. Tom from Europe, that's kind of the mastermind and the de facto answer guy for all questions on Grid Engine. The ROCks and the Grid Engine mailing list and everybody that has ever helped me there. Rich and Amber for helping us with the media coverage, and all our friends and collaborators in academia, industry, and media, including GitHub, the High Charts, insideHPC, Intel, and the International Science Grid this week, and MATLAB and NVIDIA, and finally, HPC Advisory Council for the opportunity, and Stanford for hosting the event. If you have any questions, I'll gladly take them. Yes, ma'am. It's still a manual process, but since they know their priority depends on them letting us know of the publications, so they take initiative in letting us know that they have published a paper. And all we have to make sure is go to the acknowledgement section and make sure they have actually acknowledged using of our resources to give them credit. So that's been fairly easy so far, but keeping track of violations is through automated process. I have two scripts, one that kicks them out of login nodes for doing something that they shouldn't be doing, and another script for disk usage violations. But in violations on the social media, that I depend on my friends and colleagues because not everybody's profile is public, but some of them have been not so smart enough to keep their profiles private, so I do know who they are. And the town that I live in only has 2 degrees of social freedom, so you can only be friend's friend, and so that helps along the way as well. Well, not necessarily, but they do know that we are pushing for a greater goal that helps everybody in the community. One of the projects that we haven't talked about here, or 2 of the projects, is one called Friends of the University program. Bigger the computing infrastructure, even with 5 or 10% spare CPU cycles, we could cater to the needs of every industry, small industry that's in our area. And to give you a cost-benefit analysis there, a computing cluster for them costs $100,000, and hiring somebody costs them about $125,000 per year, including benefits and everything else. And over a 4-year cycle, you're looking at $600,000 that they could better spend on hiring somebody to do real research and science and engineering than just manage the machine. And we have the resource. They could tie into our projects and use that $600,000 in hiring some of our graduates that want to stay back in the area and live there. So there is that direct benefit to our own students and to the industry as well. Yes, sir. Yes, and that's where we are looking into the impact factor of the journal to take into account some more quality of the journal. Along the lines of more socially responsible aspects, a project that I didn't talk about was called Project Greenstone. Stones, it's a rock, and since we use rocks cluster distribution, it's one more rock in a set of rocks already. Greenstone comes from the name Isle Royal Greenstone, the official mineral of the state of Michigan. So it's a project that a tool set that I designed that would shut down the compute nodes when there was not enough demand for them, saving power and cooling and other things. And when the queue got higher and more jobs were waiting, it would bring up enough number of nodes to kind of get their jobs running. But fortunately, the machine's being used 95, 90% anytime, so we haven't had the need to use that project at all. Somebody, yes, sir. No, sir, they're cumulative. Yes, sir. But however, if you're part of the research group and you do good enough work and you earn enough credit and you graduate, they still get to retain that as well. That doesn't die off either. So your good work stays behind as well. So as long as the group continues to do well and they take care of the business in-house, violations are going to be individual. Once the student graduates, they're gone. But if they don't do it, they stay back as well. Any other question at all? Well, thank you.